Today we are going to explore a fascinating problem based on quadratic roots and recurring relations. The question is, if alpha beta are roots of x raised to power of 2 minus x minus 1 equal to 0 and Sn equal to alpha power n plus beta power n, then we need to find value of this Sn plus 1 times Sn minus 1 minus Sn square. So we need to find value of this. So let's see the solution. First we will take the given classic identity, which is Sn equal to alpha power n plus beta power n. They defined this recurring relation Sn equal to alpha power n plus beta power n. If they defined Sn as alpha power n plus beta power n, what about Sn minus 1? It becomes alpha power n minus 1 plus beta power n minus 1, isn't it? Similarly, Sn plus 1 becomes alpha power n plus 1 plus beta power n plus 1. And here they are asking the value of this Sn plus 1, Sn minus 1 minus Sn power 2. So let's take this Sn plus 1 times Sn minus 1. So what is Sn plus 1? Alpha power n plus 1 plus beta power n plus 1. Alpha power n plus 1 plus beta power n plus 1. This is Sn plus 1 value times what we have? We have alpha n minus 1 plus beta power n minus 1. This is Sn minus 1 value minus Sn power 2. So what is Sn? Alpha power n plus beta power n whole power 2. Let's open the brackets and multiply each and every term. Alpha power n plus 1 times alpha power n minus 1. Here, when bases are same, we can add the powers. So if we add the powers, here plus 1 minus 1 gets cancelled. So we left only n plus 1, which is 2n. So it becomes alpha power 2n plus. Now we have to do this alpha n plus 1 times beta n minus 1. Now you have to start with beta power n plus 1. So that is beta power n plus 1 times alpha power n minus 1. Plus beta power n plus 1 times beta power n minus 1. When bases are same, we can add the exponents. So just add the exponents. Here also we have plus 1 minus 1 gets cancelled, so we left only 2n. Minus, so we are done with multiplication of these two terms. Now we have to do alpha power n plus beta power n whole power 2. Actually it is in the form of a plus b whole square. So let's use the formula. One is a square, which is alpha power 2n plus b square, that is beta power 2n plus 2ab, that is 2 into alpha power n times beta power n. Here we have a minus. So once we open the bracket, all the sign will be changed. So just open the bracket and change the signs. If you open the bracket, this becomes minus alpha power 2n minus beta power 2n minus 2 alpha power n beta power n. Now here plus alpha power 2n minus alpha power 2n gets cancelled, and here we have plus beta power 2n minus beta power 2n gets cancelled, so we left only these three terms. Here we have alpha power n times beta power n. So this we can write it as alpha beta whole power n, isn't it? And this alpha power n plus 1, we can write this as alpha power n times alpha. Same like that, beta power n minus 1, we can write this as beta power n times beta power minus 1. Beta power minus 1, we can write it as 1 over beta, isn't it? Plus, now here also we can split it each and every term. Beta power n plus 1, we can write this as beta power n times beta. Then times, here alpha power n minus 1, we can write this as alpha power n times alpha power minus 1. This alpha power minus 1, we can write this as 1 over alpha minus 2 times alpha beta whole power n. Now observe the first two terms. Here we have a alpha power n times beta power n, and here also we have alpha power n times beta power n. So let's take alpha power n times beta power n as common. So then we are going to left, if we take alpha power n as common, what we left? Alpha times, if we take beta power n also common, what we left? 1 over beta. So this we can write as alpha over beta. Plus here also we are taking alpha power n times beta power n as common. So what we left? We left beta times 1 over alpha. So we can write this as beta over alpha minus 2 times alpha beta whole power n. Here alpha over beta plus beta over alpha, if we take LCM, the LCM is going to be alpha times beta. The numerator turns into alpha power 2 plus beta power 2, isn't it? So here alpha power n plus beta power n, we can write this as alpha beta whole power n, and denominator we have a alpha beta. So if we take it into numerator, then it is going to be alpha beta whole power minus 1, isn't it? So the denominator if you take it into numerator, then it is going to be alpha beta whole power minus 1. Now observe this alpha beta whole power n, alpha beta whole power minus 1, the bases are same. So if the bases are same, we can add the exponents. So this to become alpha beta whole power n minus 1. So after simplifying these steps, what we left? We left alpha beta whole raised to power of n minus 1 times alpha power 2 plus beta power 2 minus 2 into alpha beta whole power n. So we left this. Now what they given? They given a quadratic equation, which is x raised to power of 2 minus x minus 1 equal to 0. And here what they said, alpha beta are the roots. So let's take the quadratic equation. So this is the given quadratic equation. So what they said alpha beta are the roots. So if we know that the sum of the roots, the formula is minus b over a, and product of the roots, the formula is c over a. So in the given quadratic equation, the a value is 1, b value is minus 1, and c value is minus 1. So let's substitute here. Minus, the b value is minus 1 over 1. So minus into minus plus. Finally, sum of the roots, the value is plus 1. Then product of the roots, which is c over a. C value is minus 1 over a value is 1. So that is only minus 1. What we know sum of the roots is plus 1. If we do square on both sides, then we are going to get alpha power 2 plus beta power 2 plus 2 alpha beta, that is equal to 1. From here, alpha power 2 plus beta power 2, that is equal to 1 minus 2 alpha beta, isn't it? So here 1 minus 2. What is alpha times beta? What is the product of the roots? Minus 1. So let's use minus 1. So minus into minus plus. So 1 plus 2, which gives 3. So alpha power 2 plus beta power 2, the value is 3. So this value is 3. So let's substitute here. And what is alpha beta? The value, alpha beta, the value is minus 1. Let's substitute here minus 1. Minus 1 whole raised to power of n minus 1. So alpha power 2 plus beta power, the value is 3. So we already written minus 2 times alpha beta, the value is minus 1. Minus 1 whole raised to power of n. Here minus 1 whole raised to power of n minus 1. Minus 1 whole raised to power of n times minus 1 whole raised to power of minus 1. So when bases are same, we can add the exponents. Then it become minus 1 whole raised to power of n minus 1. Isn't it? Here I am splitting because second term also I have a minus 1 whole raised to power of n term. So that's why I split it. Then I can take it minus 1 whole raised to power of n as a common. So if I take minus 1 whole raised to power of n as common, then I am going to let minus 1 whole raised to power of minus 1 times 3 minus 2. If we have a power of minus 1, we can write this as 1 over a. Similarly, minus 1 whole raised to power of minus 1, we can write it as 1 over minus 1. Is nothing but minus 1. So minus 1 whole raised to power of minus 1 is nothing but minus 1. So minus 1 times 3, which is minus 3. Minus 3 minus 2, which gives minus 5. Minus 5 times minus 1 whole raised to power of n. So this is the result of this given question. But here we have a negative value. If you want to remove the negative, we can write this as, this negative we can write this as minus 1 times 5 times minus 1 whole raised to power n. Now observe here minus 1 and here minus 1. Here both bases are same. Then we can add the powers. So this 5, write it here. And what we left here, bases are same. We can add the powers. We can write n plus 1. So the final result is 5 times minus 1 whole raised to power of n plus 1. This is the value for Sn plus 1 times Sn minus 1 minus Sn whole power 2. That's it. If you like this content, please like, share and subscribe to my channel. Thank you for watching.